All right, Monday, 10 o'clock. I'm in the warehouse, and Scotty has just got all of my tools. Got to have this tool for sure. Out of truck number 8 right here. So we're getting ready to get him set up on this truck for maintenance. You can see it's all nice and cleaned out and not real super organized yet. We don't have everything in here that needs to be in here yet, but that's what we're working on today, and then I'm get to move back into truck number 2. Finally got the transmission replaced on this truck, so it's back going. Got some other cosmetic stuff that needs to be done. Paint is chipped on the back door. You can see right there, I need to redo my wrap. Has some issues up there in the front. I've got some issues right here. It's cracking right there, but hey, it works for me. Get a good cleaning on it, wash it good, clean it out inside. It'll look a lot better, and I'll be back in it. So excited to get that back and get that going. So what are we working on this week? We got Jonathan starting on an install project today that we started last week on Tuesday. We did the tear out. There's some video footage from that. We're actually doing progress filming on that. So I got to go out today and do a little bit of filming on what he's working on. He's working on sealing some returns, pulling some wires, things like that. Dustin's going to the market project where we're putting a new system in the storage area. Zach and Brian are working on maintenance and some service. We've got some calls coming in, starting to warm up. Still a little bit cloudy, but got a little bit of humidity going on, so people are starting to turn on their ACs. And this week is definitely supposed to warm up. Sunday, Mother's Day coming up, is supposed to be 95. So definitely going to flush out some of that broken AC calls probably. We'll see how that goes. Typically, we like to do maintenance, make sure we're not going to have any problems. So this morning, Scott's washing trucks. One thing we like to do when we are washing truck number 8, we like to spray down the tires with a degreaser right here and scrub them really well, and then spray down the side of the van with an actual soap mixture, and then wash it as well. So updated the hubcaps on these a while back to some bright shiny silver hubcaps, and so it made the truck look a little better. But hey, this actually right here is the first truck we ever bought when we started buying the Chevy Express vans. I think it has almost 250,000 miles. No, almost 350,000 miles. These trucks, they're not bulletproof, but they're real close to it. So let's get cranking. So you can't even clean up on the inside of the return, like inside the house, like vacuum them out and line them. Oh, I see. Oh, okay. Well, I just figured you could just do what you can. I mean, you're there this morning already, right? I mean, okay, well, do that. No, that's fine. I mean, I knew that when you got there that the plumber might be working in the crawl space. Right. Yes. Okay. Okay. Okay, so he'll be completely done after tomorrow afternoon. Okay, that's good. We can work with that. Yeah. Well, go ahead and do what you can, right? I mean, you're there. Sure. Okay. Yeah, let's do that. Sounds good. All right, I'm gonna plan to come by there later this morning. I mean, it's already late morning, but later, and we're gonna look at, where the pillars are at, so we know how to design the ducting and all of that. Okay. Well, they might, but we can still kind of poke our head and kind of look and see. We should be able to do that, I think. I haven't designed it at all because I didn't want to do a big design and then it's not going to work. I just wanted to look at it together, then we'll decide, and I can design it. Because I want to get it designed by the end of today. Okay, perfect. All right, talk to you after. No, that's good. I appreciate that. I'll talk to you a little later then. All right, thanks. See you. All right, so Jonathan just called me, said that plumbers are working under the house on this project. He's not able to do quite as much work today as what he wanted, but he's going to go ahead and seal returns and do some of that kind of work, and then we're going to actually figure out how the duct can be designed, because we're dealing with pillars. The crawl space is limited as far as the actual height. It's not a lot of room, so we got to be very strategic in how we design the ducting so that we don't just draw it and then it's like, oh, it's not going to work that way, because it affects what kind of materials you order and so forth. So we'll try to knock that out today. Okay, so I'm here on a project that we just installed in the last couple weeks. It's been here just a little while. You can see the rain has already washed some dirt up on it, just a little bit, but this is a brand new system. This is an actual XR14. You can hear it run here. XR14, and it has, let's see, this is a 3.5 ton system. So you can see just a couple things that we like to make sure we do really well on when we're installing is our low voltage and our high voltage connections are easy to get to, well made up. This is easy for a technician to be able to undo his connections and check for low voltage or high voltage as needed. This is still a very basic unit, good solid quality, but very basic. You see you got a defrost control board here, you've got a simple main outdoor relay or contactor and a capacitor. So there's not a whole lot that can give trouble on this. I'm doing the startup today, and so while I'm doing that, I'm monitoring refrigerant levels here. So I need to select my refrigerant type, which is R410A. And so you can see I'm running at 9.5 degrees actual superheat, 8.5 degrees actual subcool, which is excellent. And I'm got my airside temp, so I've got my temp sensors in place on the return vents, and I've got 46.2 dry bulb, 68.4 dry bulb, and then I've got my wet bulb measurements. So there's my relative humidity, dew point, and the ultimate number that I'm always looking at is my delta T. So I'm at 22.7 degrees delta T, which is excellent. I'm measuring refrigerant levels right here. I'm measuring all of this through these gauges right here. So these are my ports that I've got these fastened onto. Got refrigerant, temperature, and I've got actual temp sensors in the actual vents that is measuring these measurements inside. The cool thing about this, digress for a moment, this is all wireless. It uses I think it's 2.4 gigahertz signal, something like that. So it's similar to Wi-Fi. So I can walk, as long as I'm within 300 feet, I think it is, of the sensors, I can walk anywhere on the property and it will read all these measurements to me. So it's very nice, especially when diagnosing electronic expansion valves. Don't have to do a lot of that anymore, but it is something that we have to do at times. You can see my drain is working quite well, coming out the hole, coming out of that drain pipe right there, so that's excellent to see that. And I'm going to be checking some amperages right now, so I'll take my amp clamp, come up here, actually go right here. So this is reading amps on the compressor and the fan motor, so I'm at 10.37. I can take and check my compressor, just my compressor, so I'm at 9.85 on the comp. And let's find the outdoor fan motor, which is right there, so 1.23. So checking the amperage coming into the contactor gives me the full reading. This gives me the individual of the two different components that I'm measuring. Right there and there. Okay, all looks good. Okay, we're here at the indoor unit. These are actually the sensors that I use for checking airflow. This is one's for the return, and then I've got another one over there for the supply. This is the filter access right here. So this particular system received a MERV 11 filter. This is the model number for the replacements made by EnviroWise, and it bolts just right onto the air handler. So all the air passes through here, across this filter, and comes in filtered through the system. This is where we connected our refrigeration tubing, our drain, electrical's down there. So everything is, yep, good to go. Looks good. All right, so it's 12 o'clock on Tuesday. I'm headed to lunch with John Kaiser. He's in my networking group, and he called me just here at the last minute, said he was going to be in our local town here. So I'm going to go meet with him for lunch real quick. Was working this morning with Jonathan, got him working on a project at my personal home actually. He's doing some insulating for me, pulling a wire, just some simple stuff on a garage project I have going on. And Scott working with him to get him up to speed for maintenance, and he's actually beginning a maintenance job this afternoon on the office system. So we're going to start that today. I just talked to Dustin, needs a filter dryer and a thermostat for his project. So we're going to make sure that gets delivered to him by around 2 o'clock this afternoon. And Cliff is busy in the warehouse, Zach's out working, Brian's out working, and it is warming up. I can feel it in my bones. It's going to get busy here over the next while. I guess we'll see for sure, but it sure seems like that. Anyways, so, yipper. So we've got some things to work on this afternoon. Working on finalizing a couple projects that are being quoted right now. Closed on one this morning, real small project, installing a duct on a mobile home trailer. So quoted that, and we're getting that done. Finished up on my project yesterday evening late, and got that project commissioned, and I got the project collected on. So that was great, and it was really nice working with the clients there. They have been customers of ours they've been clients of ours for years. I hadn't went back and looked to see how long, but long time, and they finally needed to replace their system. It was original to their home, and we installed them a nice new system in and finalized everything. Finished up last night at about 7 o'clock. So a little later than normal, but it was enjoyable, and we had a great visit together. So, yep. All right, so what'd you learn on the video about refrigerant and the refrigeration circuit? Some of that kind of stuff. Tell me a little bit. Oh wow, you got a bunch of notes. All right, check it out.
I learned the code, the PV equals nRT.
Good notes.
The pressure and volume equals mass and temperature.
Okay, so yeah, he talks about a lot of technical terms, more so probably than anything.
I felt like that was important.
Yeah, no, it's great. That's stuff that I don't even necessarily know.
I don't know it either. I
Okay.
wrote it down so I can learn.
Yeah, no, that's good. That's good. Okay.
But you got 4 components in order: the compressor, condenser,
Okay.
metering device, and the evaporator.
4 components. All right. All right, so tell me, what does the compressor do?
It increases the pressure.
Okay, so the compressor is the pressure increaser. All right. And what comes next?
The condenser,
Okay. What does the condenser do?
it rejects the heat.
Okay. Heat removal. All right. And then the
metering device
okay.
drops the pressure.
And by dropping the pressure, we make it so that
The temperature decreases.
correct. So it's pressure reducer, essentially. All right. And then the final component is
The evaporator,
yep. Okay.
it absorbs the heat.
So it's a heat absorber. All right. And that's our refrigeration circuit right there. So out of these 4, compressor, condenser, metering device, and evaporator, I don't think he touches on this maybe, but where could you most likely have a restriction happen at?
A restriction happen?
Yes.
The metering device?
Correct. Absolutely. And that is your restriction point. So if you ever have a restriction that's where you would go to. Now, did he talk about the different types of metering devices there are?
Yeah.
Okay.
There's the.
So let's talk about that a little bit. Whoops.
You got the TXV.
Okay.
I don't know how to pronounce it, but it's the capillary.
Capillary tubes.
Yeah, capillary
Yep.
tubes.
Yep.
And then you got the piston device. And then you got the new one that is coming out, the EXV, the electronic device.
EXV. Yep. You also see that referred to as EEV as well, either one. I don't know why they put an X in there on the TXV. It technically is a TEV because it's thermal expansion. Expansion starts with an E, but they put X in there because people. So TEV is an also and EXV. So yeah, okay, good stuff. So tell me a little bit, when I'm looking here at superheat, subcool, how do I decide when I'm going to check superheat and when I'm going to check subcool?
That's a good question.
Okay, so I don't know if he talked about that at all. So the way you determine that is that your piston and your capillary tube, they both fall under a category called fixed orifice. Fixed orifice means that it's got a hole drilled in it, literally, that's what it is, and it doesn't change. It's going to let a certain amount of refrigerant through, and that's it. When you're running a fixed orifice system, you're going to check superheat, and you're going to look for typically 8 to 10 degrees of superheat. Okay, so that would be a key thing to remember when you're in the field, because that's something you're going to run into a lot. Look at you telling me that you didn't do good on tests and that you weren't good in school. Anyone who makes notes like that is not half bad in school.
Oh, I didn't do this in school.
Oh, you didn't do that in school. Okay, good. All right. So next is the EEV, the TXV, and that would be the main ones right there. Those fall under the category of, basically, they're an adjustable metering device, right? So being they're adjustable, they can allow less or more refrigerant to flow through the coil. When you're working with one of those, you're going to be checking subcool. Now, it never hurts to look at your superheat and your subcool both, but just know that you need to identify, is this a system with adjustable or fixed? And then what kind do I have? Do I have an EEV, a TXV, a piston, a capillary? Because that will help you, if you are dealing with an issue on your refrigerant side, that will help you determine what am I going to do next for my diagnosis. Okay? Now, this is just kind of an introductory course at this point. We'll dig deep on your big ones are going to be the TXVs, and then we're also dealing with some EEV stuff. But the EEV stuff is not, we're trying to stay away from it where we can because we see intermittent issues with it.
Yeah.
A TXV, typically it either works or it doesn't, and it's a mechanical device, and so we have a lot. As technicians in the field, we feel like we have a little more control over it, and we can manage the problems that occur from it a little better in real time. Whereas the EEV, sometimes it just won't work at all, and there's not a quick fix, you know. So, anyways, okay. So does that give you enough introduction to the refrigerant circuitry? That's the big one there. So now we're going to talk about pressures a little bit. Pressures are, a lot of people that are new to the industry, even sometimes experienced technicians, will say, well, just tell me what pressure it should be reading. It's like, it's not that simple. It's back to the superheat, subcool, right? We want to check those. And by the way, like this guy that you're watching, Brian Orr on YouTube, he is doing an excellent job of teaching and using the proper how would you say, the proper techniques for you to learn the refrigeration circuitry and how to do all this. But a lot of guys still today are using the old manifold gauges, and they don't know what to do if they don't have a manifold. They're just lost. And I get it, because I kind of, felt the same way when I first started using digital gauges. But you're getting an excellent introduction to how to do this correctly, to build a proper picture of what the system is really doing. Because you're already checking the superheat subcool, you're measuring suction pressure, suction temperature, and liquid pressure and liquid temperature. When I first started, my dad used to send me to a call, and all I did was hook up my gauges and check liquid pressure and suction pressure, and that was it. And I'd be like, well, it's reading 65. You think that might be a little, let's shoot a little gas in it and see if it comes up. All right, shoot a little gas in it. Is the suction line cold? All right, beer can cold? All right, we're good. And that was how we went about it. But we missed a lot of problems that we could have potentially fixed that would have prevented other issues. So I'm going to wipe all this clean, and then we're going to talk about pressures a little bit. And we're going to talk about refrigerant types. So right off the top of your head, tell me the two refrigerant types that we're working with primarily.
R410 and then R22A.
Correct. So we're dealing with R410A, and we're dealing with R22. Now, R22 is in a phase-out process. Well, has been for the last 10 years, actually. But we're converting systems over that we work on. We're converting them over to R422D. And that's a whole other topic, but just know that we use these two terms interchangeably. We make sure that we're using them properly. All right, so we're here. This has got the condenser set right here. We've got our new line set cover put on. We've got our refrigerant tubing ran in. We've got our whip ran from over there to here. So it's all coming together nicely. Looks good. Hey guys, so today is Thursday. It's almost 7 o'clock. First time I've had a chance to film today. Busy day. B&I, of course, this morning, and spent quite a bit of time working on sales projects. It was a fairly warm day today. Zach diagnosed a defective compressor. Brian had a couple from yesterday that I needed to follow up on. So quite a bit going on. Got some new shirts in, so I was trying them out. And anyways, so Dustin installed a condensate pump on a mini split today, and Jonathan was working on his duct replacement project with new systems or new units. So anyways, I don't have it all in my head exactly what was going on today, but anyways, it's a good day. It's definitely warming up. Summer's here, and we're pushing on. And yep, see you tomorrow. All right, Friday, 11 o'clock. I just finished up washing my truck, getting it all clean for the week. So Zach is on a call this morning, a service call that he's turning into a potential sales call. So he's experimenting. He just called me and gave him a couple tips. One of the questions the client had was, hey, if I do financing through like Green Sky, Wells Fargo, is my payment immediately due the moment that I apply, or when is my payment due? And the answer is complicated. It's simple but complex a little bit, because once you apply for financing, you have some time between when you apply and when the actual system's installed, and the money or the invoice is turned into the finance company. So literally it can be a week or two before the system gets installed, once everything's complete, and then you've got maybe a couple days for the financing to process. So literally, in some cases, it could be as long as 2 months after the system after you apply originally, before you would actually have any kind of a payment due. Probably within a month in most cases. So good question, something I haven't gotten a lot of in the past, but it's an excellent question. It's good to address. So on this particular job, he is quoting a run-through system. However, as him and I discussed, we always offer 4 options to our clients so that they have a wide variety of options to choose from. And my reasoning for this is sometimes a client may say, well, you know, I want the most budget-friendly thing out there. I get that and I respect that. However, at some point, you never know, but at some point that client could potentially be living in a home where they want to invest in that really nice system. And I feel that every time somebody goes to make a purchase, I don't care if it's a car, a house, an air conditioner, you need to know within reason what all of your options are potentially. Even though you're at the point in life where you can only afford a certain amount, that's fine. But what would be an option for you down the road? Even if you don't choose it now, you need to understand what those options are. That, as a salesperson, I owe that to you, the client. So, always offer 4 options in our case, is what we do. If you're a salesperson out there for anything, always offer options, not to try to get a client to buy more. That's not the goal. It's to educate and to understand really what their needs are. Understand that sometimes people don't know what they want. They may say they want something that's budget friendly, but when it comes down to them understanding the value behind the different options that are available, they will actually upgrade. And they'll be happy they did it long term, not just in the short term. They won't have buyer's remorse, but they will be happy they did it long term. And that's ultimately, as a person that is doing any type of selling, that is what your job is to do, is not to try to manipulate in any way, but rather educate and prepare the information in a way that is easily comprehended. So that's my bit for the morning. All right, so I had a little issue here just a few minutes ago where we went to change a coil, and it was not the coil that was ordered, was a cased coil, and we thought we'd be able just to slide it right into the new case, but turns out it was not the same brand, so therefore it was not the same size, so therefore it did not fit correctly. It was too tall. So we're getting the correct one now from a vendor, so we had to put a little fire out and do a quick little bit of research. So when you're replacing coils, just be sure before you actually, number one, if you're the technician on the call, this is so important, make sure that the coil that you're replacing with is the correct size. Number two, if you're the technician actually, did I say diagnosing the coil or replacing the coil? Diagnosing the coil, make sure it's the same brand and the same size that you're ordering. If you're the one replacing it, be sure to go and measure the coil that you're replacing and measure the coil that's going in place. So before you reclaim, before you cut anything loose, because then if you have an issue, you're protected and you can leave the system like it is and come back to it once you have what you need. As it stands, we didn't know this until now, after 12 o'clock or right at 12, and we're scrambling. But if we'd have known this morning at 9 or 10, we'd have been able to make some phone calls and been that much further ahead. So not anybody's fault really, it's just education and awareness. And I'm going to add it to the processes board under evaporator coils about making sure when you're diagnosing to measure and document, and when you're replacing, measure, double check, verify, and then move forward with the repair once you verified. The tech got onto the job. Dustin was the one on the job. When he got on the job, he went ahead and removed the coil and discovered that the coil that we had purchased was not going to work. And that is a tough situation to be in, because now you've taken this in this case was a working system. You've taken it offline, and now you've got to put it back online, and the customer is expecting it to be working yet that day. You haven't prepared them that, hey, you might be without air for 2 or 3 days, and it's Friday, so automatically, if you can't get the right coil, it's Saturday, Sunday, Monday, that's 3 days. So we got really lucky, and we were able to get our hands on the correct indoor coil. Job was able to be completed. Everything was done, and we got off easy on that one. But when summer gets dumped on you, you have to dot your I's and cross your T's. And it's very important. So you got to make sure to be exact in what you're doing, not only in your technical work, but also in your setting expectations with customers. So you prepare them maybe for the worst and deliver something a little better. So the old adage, under promise and over deliver, I think it is. So anyways, yep. So let me get busy here. Hey, that's it for this week's video. Thanks so much for watching. Click here to subscribe to our YouTube channel. Click here to watch last week's video.